Well, hello there. My name is Craig Hain, and you can learn all about me at my website, craighain.com. And of course, I'm involved in mathematics education, have been for many decades now. And so you can learn all about me here, and I have all kinds of material to share with you, depending on your interest in mathematics, whether you're a homeschool parent or a teacher at a high school or industry supervisor or whatever. And if you go down over on the left side, there's a bunch of tabs, and you can get my Vita there if you want to and learn all about me. And of course, there's actually 2 videos where I discuss it along with giving you a PDF of the Vita. And now you've come to this video because you're interested in learning why spending more than $15 on a mathematics textbook is worse than a waste of money. And of course, that's what I propose to discuss with you and explain to you on this video. Well, the first thing you need to understand is that the root of the problem is what I call the standard math curriculum. And this is the mathematics that is taught in virtually all of our high schools and is represented in all of our textbooks and our math programs that teachers are using today. And it, of course, is the root problem. Now, the question is, what's wrong with the standard math curriculum, what I call the SMC? Well, there are several things. First of all, the standard math curriculum today has evolved over a century, 2 centuries really, and it is loaded with obsolete topics that are of no real interest to students regardless of what their total interest in math might be. It's just loaded with obsolete topics that it's picked up over the years. Furthermore, it's often loaded with topics that are premature. In other words, you're presenting things to students long before they're ready for them with most of the standard math curriculum textbooks. And then, worse yet, it's missing many important and necessary topics for students. And that's very bad also. And finally, and perhaps worst of all, it's missing important modern tools that make the practice of mathematics and the learning of mathematics much, much different than it was 20 years ago or 50 years ago and the time when this whole curriculum evolved. So now, as we go along here, I'm going to try to explain to you why this is and give you some ideas of what to do about it. Because one question you're going to ask is, well, if that's true, if I believe you that it's loaded with obsolete topics and has a lot of topics that are premature and it's missing important topics and it's missing important tools, how can I evaluate a book or a math program? How am I going to know this? And of course, I'm going to answer that question for you. I'm going to show you what I believe a good 21st century math curriculum should consist of. And then you can use that as a benchmark or a reference to evaluate any program you might be considering. And then, of course, you're going to say, well, what textbooks, if any, should I use? And there is one that you should know about, and I'm going to be telling you all about that. And then I'm going to conclude by discussing with you how a child should be taught mathematics. And indeed, I think homeschoolers do a very good job of that. It's very difficult for public school teachers in classrooms. And then finally, how can I learn more about the best way to teach my student mathematics? And of course, I'm going to explain to you how you can get a lot more information. Okay, question number 1 now. How can you evaluate a book or a mathematics program you might be contemplating using, or maybe one you are using? How can you evaluate it and decide whether or not this is true or not? Well, the way you can do that is to compare this to the table of contents of a program we've developed. It's a 5-tier program that starts with most basic mathematics and goes all the way through calculus. And you can compare what we've done with this ground-up design program to whatever it is you're using, and you can make decisions and evaluations based on that. So how are you going to do that? Well, we're going to give you the table of contents of our entire program so that you can know what is in it. And what we do is we start out with what we call the Practical Math Foundation. And the very first thing we do is we teach the student to use the modern tool of the scientific calculator. Now, the scientific calculator we use is the Texas Instrument 30XA. It costs less than $10, and it is an absolutely magnificent tool. You only need to use about half of the functionality on this, and that's what we teach the student to do, because we're going to teach them how to do all the arithmetic calculations for practical mathematics using this calculator. Now, the syllabus for that, or the table of contents, are 16 lessons that we teach the student. Each one of these, then, is a video lesson with exercises and a quiz to verify they've learned it. And it's all delivered through our learning management system, so you and the student and myself can keep complete track of this thing. And these are the things that we believe you should teach your student the very first thing. It takes most students a couple of weeks to go through this, and they love it. It's very kinesthetic because they're learning how to use the calculator and learning to do things. And indeed, I imagine that you'll learn something too as you go through this. Now, the second thing we do, and we're still in what we call Tier 1, we teach the student what we call pre-algebra. And this is really being sure that they understand the rules of arithmetic and real number lines and how all of this works. And so this should be reviewed for them. These are post-elementary students, and they presumably have already learned all of this in elementary math that you've taught them already. But it's going to reinforce that and be a good review for them. Now, starting in Tier 2, we introduce them to algebra. Now, this is going to probably blow your mind when you see how many lessons there are. There are only 10 lessons in algebra. This is the algebra that you need to do practical mathematics. I'm talking if you're going to go into industry or any practical, non-professional subject, this is all of the algebra you need. We start out and we teach them all about what is algebra, what are the different ways of doing it, the rule of algebra, which is critically important, and then we teach them how to solve some very basic algebraic equations, which is all you need in practical math. Now compare that to an 800-page Algebra 1 book that you would typically buy in a standard curriculum course. Then in Tier 2, we teach them geometry. Now this is the geometry that we teach them, and it is basically the geometry you need for practical mathematics. It does not involve proving theorems. We do give rigorous heuristic demonstrations. For example, we show them how the Pythagorean theorem works. The most important topic in this whole thing is similar triangles, because now we have enough algebra to use similar triangles and combine algebra and geometry to solve all sorts of practical problems. This is not typically how it's done in the standard math curriculum. And so you can go down and look at all of this. And then you always ask yourself, if you're evaluating another curriculum, is what do they have that's not here, and would it be premature or in fact obsolete? We finish the Practical Math Foundation with trigonometry, and there are 8 lessons in trigonometry, really 7, because the last one is just telling what's going to happen beyond practical math. And this is something you need to solve any kind of a triangle problem. It's an extension of algebra and geometry, and it's only 8 lessons. It's really quite easy, and the students love it, and then they can do the practical problems they need to do that otherwise they're not taught. In fact, they're taught things now in this Practical Math Foundation that they would not get out of the standard math curriculum until they were either juniors or seniors and had gone through a tremendous amount of material that was irrelevant. Well, now you may reasonably ask, what textbook do we use with this program? And the answer is there is no mathematics textbook I know that does these topics properly and adequately, so we use our own notes. This is the Practical Math Foundation notes that we create with the notes, the exercises, and everything that goes with this online program. And we will share this idea with you, and you've seen the syllabus of it. So basically, we don't have a textbook that we can even recommend to you. We have to use our own custom notes. Now, this is the Practical Math Foundation. It takes most students less than a semester to go through the whole thing. And when they get done, they know more mathematics than 95% of U.S. adults, and they're ready for a non-professional technical career. Go into an apprentice program, tech school, military, what have you. But if they're going to go on to college, they're going to need more additional math training, which we're going to then do in Tier 3. So now for students that want to go on to college, they need to do well on the SAT, whether they're going to be STEM students or not. And in Tier 3, we start going through a bunch of topics that they don't need for practical math, but they're going to need to do well on the SAT and the ACT and so on. And now we, for the first time, begin to use an actual textbook I'm about to tell you about, a mathematics textbook. And we have custom notes for some topics, but mostly we use this textbook I'm going to tell you about. And then we have a lot of practice on the SAT, because really that's the key to doing well on the SAT, is to do a lot of practice. Okay, now we use a mathematics textbook for the first time. It is a wonderful book by a wonderful teacher named George Simmons called Pre-Calculus Mathematics in a Nutshell. It was first published in 1987. This was a Barnes & Noble edition that came out, I think, in 1992, which was when I first learned about it. It's only 119 pages long. It covers geometry, algebra, and trigonometry in all the depth you need for pre-calculus mathematics, certain at that point in time. And in Tier 3, where we're getting people ready for the SAT, we only need to cover about 20% of this book. In fact, all we need to cover are a few topics out of algebra. They've already got enough geometry and trigonometry from the foundation course. And so we cover about 20% because this is a very, very deep book, and we don't want to give students more math than they have to do well on the SAT, unless, of course, they want to go into STEM. So this is the book I recommend to you. Now, you can go to Amazon and type in this George Simmons book, and the paperback edition today, brand new, is somewhere between around $15. And as a matter of fact, the one I use is the original hardcover from Barnes & Noble, which you will have to buy a used version to use the one that I use, but it's essentially the same book, so you can use either one of them. And so this is the only textbook that I use in all of the training that I do. And of course, I use part of it now, as I've already told you, in Tier 3. On this website, you can go down and learn about George Simmons, for example. There's editorial reviews, and it talks about George Simmons. He graduated from Caltech. He went to University of Chicago for his graduate degrees and to Yale. He's got previous books. In fact, I was teaching out of topology and modern analysis in the late 60s and early 70s. That's how I got to know him. And then later, much later, he came out with this book, and it's fabulous. And it's only 119 pages, and it's just a wonderful book. I highly recommend to you, no matter what you're doing in mathematics, get this book and get yourself acquainted with it. Just read his prefaces and his introductions to all the different sections. That alone is worth the price of the book. Now just compare this to any of the standard curriculum books. Here's Algebra 1 Common Core Student Edition, put out by Pearson. And you go down and look at this thing, and it turns out when you go look at it, it has 946 pages on this thing. Now, just imagine all the stuff that's in this book that you don't need. It's just full of stuff that's irrelevant, and it also has a lot of things in it that are way premature, and you just don't need it. And of course, it's pretty expensive, too, on top of that. And that's true of the Algebra 2 books, the geometry books, the calculus books, you name it. And now I'm going to tell you what we do after Tier 3. Now, Tier 3 has got your student ready to do well on the SAT. We've given them enough mathematics they need, even though a lot of it they'll never use, but they'll do well on the SAT. Well, are they ready now to go into a STEM major, science, technology, engineering, and math? And the answer is absolutely not. Nowhere near ready. They need a lot deeper treatment of geometry, algebra, and trig to do that. And so now in Tier 4, we now go through the George Simmons book in great detail and in depth. And it's a tremendous thing to do. It takes about a year for them to go through it. And so we start out and we cover a lot of the geometry that George does that we haven't already done in the basic. There's a lot more he does. It's just fantastic. You have to read it to appreciate it. And then and when we get into algebra in George's book, in the 5th lesson, we introduce the student to the wonderful tool Wolfram Alpha, which is an incredible tool for this 21st century. It's only been available since 2009, and it totally changes the way you do mathematics and should teach it. And so when we do conic sections now out of George's book, we also use Wolfram Alpha, and we begin to do all sorts of things with Wolfram Alpha now that you cannot do any other way. George would have been absolutely thrilled with a tool like Wolfram Alpha, but of course it didn't become available to 2009. And that follows all the way through trigonometry and everything we do in George's book. And in fact, if you want to see Wolfram Alpha, you should go to it. Here's the Wolfram Alpha website. Here's an example. I entered a rational function and asked the Wolfram Alpha to show me its asymptotes. And it did so. And here it tells me it's vertical asymptotes. It has parabolic asymptotes as x goes to infinity. It graphs it. And this is just a small sample of all the wonderful things Wolfram Alpha will do. And you'll need to use it from this point forward in teaching STEM mathematics to your students. Now, in addition to Wolfram Alpha, that wonderful tool, you need to teach your student all about complex numbers in pre-calculus. And we have 11 lessons on it, and this is never done properly in any book I've ever seen in pre-calculus mathematics, and it needs to be done. And this is a wonderful thing your students need to learn about. And so this is one of the gaping holes in the standard math curriculum. And now some really bad news from the math education community. Calculus books like this, 9th edition, which is a very thick calculus book that's used typically in colleges today, or books like it. This is obsolete because of Wolfram Alpha. We can teach a student all of the calculus that they need to know for MIT in one semester using that wonderful tool. It's 100 times easier than going through a book like this, and this book is obsolete. The same thing is true about differential equations. Okay, so what should you do? Well, obviously buy a George Simmons book and learn from it. Opt into our crusade. I invite you to do that because as soon as you do that, I'm going to give you 3 books I've written on the subject at various levels, a teacher's guide. I'm going to give you a whole bunch of videos for free that talk all about the teaching of mathematics from the very beginning all the way through advanced mathematics. And who knows, it may some point in the future you may want to may engage me to help teach your student as well, which I would love to do. In any event, our mission, shared mission, should be to give your student the greatest possible math education to fit their interest in life and their needs.